We talked about so many circuits, over 4 repair surveys. So after learning, we make a small summary of firmware faults of our laptop. One of our most common failures is the failure of no booting. There are still more computers that do not turn on. Let's take a computer like this one. First, we need to back off the battery. Connect the power supply and analyze the current to judge the faults. They all remove the battery and connect it to the power supply and judge the fault by looking the current state. So the ammeter is an essential tool for us in maintenance. So how do we look? We take some common failures and experience in our maintenance. There is also a magnitude of the current to determine which current is there. First of all, our first step is to look at standby current. What is standby? When the switch is not pressed. Normally, it is about 0.01 ampere and 0.02 ampere. It will not be too high. If it is too high, it means that our motherboard has a slight leakage, caused by low current. Basically, those larger than the 0.06 ampere belongs to the slight leakage of the motherboard. How can it be solved? Normally at this time, we power on to touch. Check if the chips on our motherboard are slightly hot. There are many cases of getting hot like a little bit. I will replace with a chip is slightly hot. If there is a slight heat, touch a heat it emits. We have to replace the heating IC or the capacitor around the IC. The capacitor can be removed without installation because we have set from the ground capacitance to filter. I usually find out this kind of failure. This kind of greater than the 0.06 ampere is caused by low current. In this case, we will change the chip first. If we touch which chip gets hot, we will replace it. If it's not good enough, then check the capacitor around it. Even if we check the chips, we need to know which chips to check as a focus. Generally, the possible failure rate of this chip is a little bit high. For example, EC 3V, 5V standby chip. There is also our charging IC bridge. The failure of servo chips also very high. For experience, we just touch it, including the network card. This part needs to be investigated carefully. It can be said that 80% of the problem are here. Like other chips, the failure rate will not be too high. From our experience in this repair, first find out the major chip. This is a small standby current, assuming that the standby current is 0.08, 0.01, 0.12, 0.13. It is weakly small. This is caused by low leakage. This is the first case. There is also a case where the standby current is high. When we haven't pressed the switch yet, our current pointer is above 2 ampere, and there is an alarm. higher than the standby current. What is a standby high current? When the switch is not pressed, the current pointer is above 2 ampere or even higher. The switch current pointer is not pressed to the maximum. Or the digital multimeter is above 2 ampere. A machine like this is easier to repair. Most of this type of machine is caused by the short circuit in the common point. Generally speaking, it has an 80% chance. We can measure with dial. If it is 0 to ground, then the common point is short-circuited. Or is 3 volt short circuit. 3 volt be inductor shorted. First measure the dial value of the common point to see if it is short-circuited. If you find which circuit is short-circuit, I talked about the 2 major circuits in the previous course. When there is a short circuit, we use a burn-in method to judge. The voltages from the low to high slowly touch your major chips. Then the common point is short-circuited. I will burn the common point, make a jumper to common point, and connect to the short killer. Use current to connect one end to the ground and one end to the circuit. Voltage from low to high. Generally, most of them are 3 volt chip or CPU power supply chips. The probability is relatively high. If the common point is short-circuited, it is basically a 3 volt chip. Or around the CPU power supply IC, there is also a charging IC. According to the experience, these failure rates are relatively higher. If it is a short circuit with a large inductor of 3 volt, basically check the EC and soft bridge. Therefore, when we troubleshoot each of the faults, our experience is a bit quicker than repairing the circuit. That's why so many technicians in the shop can repair most of the faults without looking at the schematic diagram, because they have a lot of experience in their minds. If you follow the drawing to check one by one, it greatly increases our maintenance costs and time costs. There are also in our maintenance, we must use it flexibly in the maintenance. Once the standby high current and the common point is short-circuited, focus on the checking the 3 volt chip. There are also capacitors around the CPU power supply chip. Then the 3 volt large inductor short circuit. We need to focus on checking EC and the surrounding area of the soft bridge. Try to be on both sides. It is very easy to damage. This is what we need to pay attention to. There is a small standby current on it. More than 0.6 ampere cause standby low leakage. This is called large standby leakage. The point must be clarified. This is the first step. If you don't turn it on, check if the machine is normal. Standby current is normal or not, which is to be clear. The second point, if the standby is normal, what should we do? If the standby current is normal, we press the switch. See if there is any response to the current, that is, if the fan works. See if it can be triggered or not. We have talked about the trigger circuit, how to determine whether to trigger. Mainly depends on whether the current reacts. Or whether our panel inductor is shining. Use these two methods to determine whether it is triggered. Then when you encounter this kind of machine, the standby current is normal and the switch is pressed, but the current does not respond. If there is no response, call no trigger. If you want to fix it quickly when it is not triggered, there is a quick fix way. Slow repair has a slow repair method, and intensive repair has a refined method. Like this repair machine, what is non-repair machine? Caused by the normal use of the customer, as well as heavy fault. There are also those that have been poorly repaired by other technicians, divided into these situations. If it is damaged in the normal use, called non-repair machine, have not been acted on by the same person, have not been used by the previous user. In this case, we usually come to our focus to check and replace the EC. Replace the EC first, because the probability of EC is higher. If it doesn't work after changing the EC, check the conditions of the EC. In turn, the effect of repairing will be higher. Power supply, clock, reset, these conditions must be checked. There is a third, and then check the bridge standby condition. Finally, replace a PCH. For a repair machine, this probability is relatively high. These are 9 major conditions of the bridge. I have told you that it is very troublesome. So the general repair master, he just did the bridge first and then thought about it. If no words, then check the condition again, because the bridge is more likely to damage than the conditions. The principle is different from the practice, and the actual maintenance and actual principle should be used flexibly. Don't let your thinking tied up by the books. You see that the information is very well written, but the actual practice is not necessarily based on the book. Books are here to increase our thinking. It's not to limit, it's to be clear. Regarding the second repair, what is a second repair? If the EC and the south bridge were not good after being replaced by other repairers, there was a history of maintenance. This kind of machine is more troublesome. For a machine like this, you open the board and see that both EC and the south bridge have been welded by other repairers. Basically, like this kind of board, the thing you need to do is to check the conditions of EC and the south bridge. Just check the standby condition of the EC and PCH. This kind of maintenance can improve one's skills, but they may not bring us to much profit. This point must be clarified. So the second repair machine and the first repair machine can be seen when we disassemble the machine and look at it. The board after water damage, you can see that the EC or the south bridge is moldly. Not only will it be bad, it is possible that the condition will also be damaged. So if we encounter downtime, we may make money or repair it faster. The second repair is hard to say. This is a repair that is not triggered by standby. This is not triggered. What are we going to talk about on the third point? If it can be triggered, we'll look at the current state after the triggered repair. It's just that the indicator light is on and the fan works. It can be triggered even if the indicator light is on and the fan is also working. This is called can trigger. If you look at the current after the trigger, we also have mentioned that when we talked about the building circuits, it may be a low current or a high current. The first one is to trigger a small current. What is triggering a low current? We talked about it when we talked about the power supply circuit. I won't go into details here. Trigger current is less than 0.4 ampere, which is called trigger low current. When encountering this kind of current, our power supply is basically not available. To check the major power supply on the motherboard, the major inductor, including level to level, voltage stabilizer, this power supply must be checked out. See which group needs to be checked in order. I won't go into details about this. You can watch our previous course, so I won't waste this time here. The second is to trigger high current. What is trigger high current? After pressing the switch, the fan turns. The current pointer directly swings above the maximum 2 ampere. This is a serious power supply short circuit we talked about earlier. Measure the value of each major circuit. This one is also easier to fix. This one doesn't matter in order. But remember to measure all. Don't miss it. Measure all the major inductor first. If which inductor is short circuited to the ground value, I will judge the front and back poles by burning the machine. It also should be noted. The third point, the trigger current is set between the 0.4 ampere and 0.6 ampere. Like this kind of current, it generally needs to be checked. Check the main power supply after triggering. But the power supply is basically normal. To prevent certain power supply from being insufficient, try to check the power supply first, then check the clock, check the reset. We talked about the reset circuit, 3.3 volt. If these all are normal, still in this position, how are we at this time? Try to flash the BIOS to prevent the BIOS bad. This does not rule the BIOS is bad, it is to prevent. Because the BIOS program cannot be measured, only the flash to try. I have talked about the BIOS circuit. If the BIOS is not working, basically the CPU is broken. This point must be clear. If it is of 0.4 ampere and 0.6 ampere swinging back and forth, generally the RAM is not working. Then the fourth case. If trigger, the current swing back and forth from 0.6 ampere to 0.8 ampere. In this case, generally speaking, first check whether our screen lights are in a good contact. It is possible that the screen cable is loose or the screen cable interface is oxidized. Check the screen and screen interface. Take a look at the screen and the screen cable interface to prevent the interface from loosening. At this time, we can generally brighten the screen and the screen is basically lit up. If yours is still not bright, there may be a problem with the screen. Let's test it with a good screen and screen cable first. So when we open the store, we have to have all the accessories. It is convenient for us to troubleshoot and use. You can say that it's a problem with the external accessory based on a signal board. I didn't say that the screen must be broken. I have to judge whether it is broken. If it still doesn't work in this case. In the second case, we have to flash a BIOS. It is possible that the BIOS program is lost and there is a problem during the self-check. What if it's still not good? In this case, we basically need to check the interface circuit of our screen. We haven't found this circuit yet. Let's take a look at the resistor of the flat line interface circuit and measure the voltage. If it still doesn't work, it may also be a CPU problem. CPU cores does not work. This is a fourth situation. The fifth situation is around 1 ampere and the screen does not light up about 1 ampere. Under normal circumstances, this is already in the system. Press the switch after the inductor light is on. The current reaches more than 1 ampere. But there's no display. In this case, consider our screen first, but the probability of the screen is not high. But we still have to check from the screen. If there is no problem with the screen, if your motherboard is a discrete graphics card, basically the discrete graphics card has a problem. Generally, we use a BGA reverse station to replan or solder the BGA chips. Use a dedicated BGA, the BGA soldering introduced in our video materials. I hope everyone will practice more during maintenance. It can be said that 80% is caused by this. If there is no discrete graphics card here, there is usually a problem with the CPU. No discrete graphics card has a CPU, especially AMD processor. If it reaches 1 ampere directly, then first consider a CPU. So this current is above 1 ampere during maintenance. It may also be 1.2, 1.4, 1.6. If you experience them, if there is no screen, you can do the graphics card first. Most of the cards to do first good, but the cost of preventing screen, especially the machine that fell heavily. If it's a heavy fall, the chances of broken screen may be higher. This is no display above 1 ampere after pressing the switch. In this case, we refer to my knowledge during the maintenance to fix a problem that don't turn on. So if you don't know the specific reason or something that you don't understand during maintenance, we will combine the live broadcast of video to answer the ammeter for everyone. Among the maintenance, basically my repair method is to repair no power on. It involves repair power supply and resetting, as well as triggering and repairing triggers. Check the condition when it is necessary to check the condition, and check the resistance value when it is necessary to check the resistance value. We must use our previous knowledge comprehensively in our maintenance. You need to practice more and you can fix faster. More repairs, more experience naturally. So our theory classes just give you an idea and method. How fast or slow you repair depends on the level of your practice. You should pay attention to this point. This is the first type of failure. How to repair it if it is not power on. First of all, 2 points must be determined. One is to press the switch and the fan does not work. The other is the fan work. The specifics still depend on the current to determine, but there is also a diagnostic card in repair. We do not recommend using the diagnostic card on the laptop, because it is inaccurate for us throughout the most machine and Mac. This can only be used for reference. The specifics are still subject to the current, so this part has to figure it out.